What is DevSecOps and how did it even start? And what were the previous models that came out before DevSecOps? And of course, they have to be all introduced to us in this wonderful theme of Star Wars. You know, no copyright or anything intended. And how does it all work? What does shifting left even mean? How can we actually use DevSecOps to make sure that security teams and development teams work well together? And finally, we have the little game that we played at the very end. I don't want this to stay on too long just because I don't want to give it away. But we played a little game at the end as well, just so we can make sure that we understood everything that was going on inside of this course or inside of this particular video. And yeah, without further ado, let's jump into the introduction of this particular room. All right, so we're gonna learn the history behind software development and how they've evolved over the years and what it actually makes DevSecOps. So DevSecOps is just a security arm of DevOps, which is development operations, essentially. And development operations refers to software development. So DevSecOps is just a branch of that, and it's a very, very important branch of DevOps, and we're just going to understand the culture and the discipline of it, and we're going to go through some of the very, very important portions of this. And this is the first room in this particular path, and this is actually something that was recently developed in TryHackMe. It is, oh no, you know what? It's 712 days old, so it is not recently developed. But it is a free room, so if you definitely want to go check this out, you're more than welcome to. And there is a view site button at the end of this where you actually get to use the stuff that they teach you. So this is a cool one. DevSecOps is a really, really big field, and there's going to be a lot of people that will need to be going into this field because it's one of those big branches of cybersecurity that there's constantly being recruiting done for. And it pays extremely well. So if you actually want to go into software development, or if you understand code and if you like code and if you want to be around the development of software, then this is one of those really big fields where you can make a crap ton of money if you're really good at it. So that's the other part, right? So you got to know what the hell you're doing and you got to be good at it. So that being said, let's actually jump into just the story behind it and what DevSecOps is, and we'll kind of get into some of the nitty gritty. All right, so here's a corny joke for you. A long, long time ago, there were waterfalls in a galaxy far, far away. That is that is the security person's version of a joke that they used that they got from. I wonder what movie this is from. Okay, so the first model for project management was called the watermelon model, the waterfall model. The first version of that was the waterfall model. And it worked based on a hierarchy, as you can see right here. And this is what kind of the term waterfall came from, right? So you start with analysis and you go down to design, implementation, testing, maintenance. And this is back in the 70s. So this is already 50 years old, okay? So the admin worked tirelessly to keep everything running smoothly and afloat, and developers built and added as many features as possible. And finally, quality assurance engineers test the system functionality, ensuring that everything worked. And if anything troubles the server, if anything needs deployment, sysadmins have to jump on it. If it's a code problem, developers will put out the fire. If there's anything to do with testing functionality, quality assurance goes into it. But what if there's a flaw, a bug? Who fixes that? And these are situations that led to many blame games and passing the baton around the creation, and then friction would have, and then backlogs would be, and everything just kind of goes downhill, not in a good way, right? So customer expectations grew, features and releases were released, and responsibilities would end up being big messes, and bugs and security flaws were again backlogged, and a lot of these things were unresolved. And this was something that ended up being a pain in the freaking ass for all the people that were involved, especially the people that are using the freaking software, right? So this and the system became a root cause of ineffectiveness in flexibility and communication across all of the teams that were involved. And then we have the agile model, which is a little bit more current. And this is what's actually happening nowadays, which is something, I mean, I've heard a lot of companies still using agile, and I see it in job descriptions all the time. Agile is not specific to cybersecurity or security engineering. It's a project management model. And so because there were so many challenges with the waterfall model, there was something that needed to be for flexibility and adaptability, and then the agile model came around, and then there's something called the Agile Manifesto. That, I mean, look at this thing. This looks, I mean, for God's sakes, what the hell? This website has been outdated forever. You can look at this, man. This is literally, just this website gives me anxiety because the image, look, this is the same image, and it's been, what is this called? Cascaded, I think. So they are using the same image over and over and over again. And just by itself, it's like, who made this? You couldn't make something a little bit more pleasing to the eye? Well, whatever. This is the manifesto for agile software development. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to the value individuals and interactions over processes, and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to challenge over following a plan. That is, while there is a value in the items on the right, we value the items on the left more. Goodness gracious. Honestly, all these people, although I'm super excited that you guys exist and you've done this for us, you could have done a better job of freaking writing this. And then we have the 12 principles of agile software, and you better guess, look at this. I'm not going to sit here and read this. You are more than welcome to go to agilemanifesto.org and read all this shit. But yeah, that's basically it. So this was developed, and yay. And individuals and interactions over processes, working software. I mean, I just read this, so I'm not going to reread this again, but this is the agile model, right? So you analyze, plan, design, build, test, review, and then launch the damn thing. And then DevOps, A New Hope. Of course, they are ripping off Star Wars as, oh my God, look at this. In 2008, a conversation between Andrew Clay and Patrick Dubois led to something quite revolutionary. Discussing the drawbacks of agile, DevOps was born. After an event in Belgium the following year, DevOps Days became the next buzzword, and its popularity increased. And it's quite different from the previous methodologies because it focuses on driving cultural change to increase efficiency. It does this by uniting the magic terms, the magic of all teams working on a project using integration and automation. With these ingredients, you can get cross-integration across all departments, quality assurance, sysadmins, developers, all at the same time. For example, ensuring developers can now be involved in deployment, and sysadmins can now write scripts. QA can figure out how to fix flaws versus constantly testing for functionality. By introducing automation and integration of systems, these engineers can now have same visibility at all times and interact accordingly. We will dive more into this in a little bit. So why is this important? If you haven't already been able to put two and two together, it's important because it makes sure everybody's using each other at the same time. Like, it's cross-pollination almost. They're working together instead of passing the baton back and forth and waiting for one team to finish while so that they can do their job. It's like, it's collaborative. I mean, you use that term a lot, you hear that term a lot, but it is collaborative, and it helps align tech projects to business requirements, increasing the impact and value of the business projects, and it becomes more efficient and prioritized accordingly. And changes rolled out are usually small and reversible, visible to everybody, and it makes everything just super fast and increased competency when delivering the work. So it's very, very important. I am not going to read this because we just went through all this stuff, but it's important to understand the history of DevOps. So that's how we got to where we are. It is the declarative approach and requires users to specify the end state of the infrastructure, deploy these machines in a running state directly into an environment, automating the configuration choices throughout the workflow. The software builds it and releases it with no human interaction. That's basically where we have ended up to now. You come with the goal in mind, and the software takes care of it for you. So very, very, very important to understand this. And I mean, we are in the age of AI, so this shouldn't be news to anybody. So I've already answered these questions, but we can kind of go through it. What methodology relies on self-organizing teams that focus on constructive collaboration, and that is the agile methodology? What methodology relies on automation and integration to drive cultural change? That would be DevOps. What traditional approach to project management led to mistrust and poor communication? That was the waterfall. And what does DevOps emphasize? It emphasizes the building of trust. So this is our little history lesson behind why DevOps was created and how it was created. So let's talk about the infinite loop of DevOps. So it starts with the plan, and we go to the code, build it, test it, release it, deploy it, operate it, monitor the damn thing, and based on all of the stuff that you found in these stages, replan, recode, rebuild, retest, re-release, etc., etc. So it is an infinite loop, as the name implies, and it never ends. Very unlike the waterfall and the agile model, it's continuous. And the infinite loop expands some concepts that we need to kind of really understand and wrap our head around. This is going to be something, again, that you're just going to run across all the time as you go into DevSecOps or DevOps in general. So CI and CD is something that comes up all the time. Continuous integration and continuous development. Continuous integration and development deal with the frequent merging of code and adding testing automated manner to perform checks as new code is pushed and merged. And you can test code and push and merge thanks to a dynamic and routine in deployment, which takes the form of minor code changes systematically and routinely. And thanks to this, it detects bugs early and decreases the effort of maintaining the code. So continuous integration and deployment. And to make something like this happen, to make this whole thing happen, you need something like infrastructure as a code. And this isn't too far from infrastructure as a service, by the way. So infrastructure as code is a way to manage and provision infrastructure through code and automation. Thanks to this, we can reuse code that's been deployed for infrastructure like cloud instances, meaning if you want to create new virtual machines, instead of redoing the whole thing, you just duplicate one instance that you created and you multiply that by 100, and you say, I need 100 new versions of this thing, and just like that, boom, you have 100 new virtual machines. Super, super easy to do, super quick to do. And it helps inconsistent resource creation and management. And standard tools are Terraform, which I've used a lot, or I shouldn't say a lot. I have used Terraform frequently enough to know what the hell it is. And again, super freaking easy, you guys. It's so easy with Terraform to create a bunch of virtual machines on AWS, for example. It's insane how easy these kinds of things become. Vagrant is another one. And we're going to be using this in the path of DevSecOps later. I don't think it's going to be covered in this room. Then we have configuration management. So we state infrastructure is managed constantly and applying changes efficiently, which makes it much more maintainable. And thanks to this, time is saved. Time is a big freaking deal in coding. And it's just a pain in the ass to just have to recode things and manually copy paste things and do a lot of things like that. You could literally just, with a couple of clicks, this is what I love about the new world. People are like upset about it. It's like, no, bro, it just saves time for you to do the really important stuff and then do more big projects and things like that. Then you have orchestration. It's just automation of workflows. Think about an orchestrator, think about an orchestra, the maestro at the in front of the entire room that orchestrates everything. It achieves stability, for example, automating the planning of resources. We can have fast responses, and it can be achieved thanks to monitoring, which is right here. So it focuses on collect data and look at the performance and stability of the services and the infrastructure. And then once you have that, you can do faster recovery, cross-team visibility, more data to analyze for better root cause analysis, and generates an automated response, as mentioned earlier. And then you have microservices that breaks an application into a lot of different pieces that allows you to figure out how to scale things if you need to grow them, reduce the complexity, or fix bugs if you need to fix them, because instead of looking at one giant thing, you can track it down to see what one specific microservice crashed or has the bug in it. And then all of this, again, goes back to the top right here: continuous integration, continuous deployment, and then you use infrastructure as a code. So this is the loop. This is literally the loop, just broken down into 6 steps right here, right? So very, very easy to understand, and hopefully you can understand why this is the preferred method right now, because it makes things easier. It makes things easier, it makes it faster and more manageable. What helps adding tests in an automated manner and deals with frequent merging of all the code's small changes, and that is continuous integration and continuous development. What process focuses on collecting data to analyze the performance and stability of services, and that is monitoring. And what is a way to provision infrastructure through reusable and consistent pieces of code? And we're going to call that IAC, which is infrastructure as code. And just like that, we have the infinite loop down. So shifting left, let's see what this is. The whole idea behind shifting left is that DevSecOps teams, or DevOps teams, they focus on instilling security from the earliest stages in the lifecycle and makes it more collaborative between development and security. So the DevOps team understands security. That's essentially what we're trying to do. And since it can be introduced early, risks are reduced very, very massively, because they're thinking about security while they're doing the developing. Before, they would do the developing, and then security would have to look at it and be like, hey, there's a bunch of security flaws in here, and you would need to fix those things and then go back into development. Now they just think about security as they're developing. Very, very basic. Security testing was implemented at the end of the development lifecycle. This was previously. And as the industry evolved, security teams would perform a lot of different analyses and security testing in the final stages of the lifecycle, and then depending on the results, they would either need to permit the application or literally go back to the drawing board. And it would cause long delays in development and friction. And so implementing security measures during all stages rather than the end of the cycle will ensure that the software is designed. I mean, this is common sense. Like, we don't need to beat this over the head, right? So it's like, if you just keep security in mind while you're doing the developing, it just makes things a lot easier. And this is what shifting left really basically means, because you're looking at this graph right here. And this is the traditional model where it would go through planning and designing. Let me see if I can zoom this in a little bit. I would go through the plan and design, development and build, and then in testing is when they started thinking about security, and then in the deployment and release is when they really started thinking about security, and then they would have to refix all the shit that was found here. When you shift this mountain to the left in the plan and design phase, and development and building phase is where most of the security conversations was done, so that as you're going through testing and deployment, you don't have to focus too much about it because most of the work has been done. And then you can try to fix bugs or new bugs as they come, or security vulnerabilities as they come around. So this is the reason why shifting left. And as we talked about in previous videos in this particular path, I think it was in the SSDLC path, as well as SAST and DAST, in these specific modules, as we talked about them, we just noticed that the cost of fixing something is so much cheaper in the plan and design phase and the development and build phase, and it's so much more expensive after you've deployed and released and you're in the actual operational phase of something. So The cost of fixing it is so much easier and cheaper, time-wise, energy-wise, money-wise, if you catch it and just focus on it in the beginning. And this is really the big piece right here, right? So it ensures these flaws are caught early by introducing processes from the start. Post-development security reviews of new software could become a bottleneck, meaning it can hold things up from being actually deployed. And even when you find a problem, it's not enough time to remediate them before the next version. So to keep up with this, you need a fast-paced environment for scaling and growth. And security is at risk of being left behind. So instilling security in the beginning becomes more flexible and adapted to a new development cycle and increases the chance of addressing things promptly, meaning quickly. And this approach to shifting left can be referred to as DevSecOps. And we are finally here. So what term is used to describe accounting for security from the earliest stages? And that is called shift left. And what is the development approach when security is introduced from early stages of a cycle? And that would be DevSecOps. And there we go, just like that. Very, very easy to understand and pretty common sense if you ask me. I mean, you should not need a lot of explanation for this, which is why I'm kind of skimming through this, because this should be common sense. So security strikes back. Now let's talk about this. And again, they have ripped off freaking Star Wars. So let's talk about this. What is this? Okay, so as the parody of The Empire Strikes Back. So this is what happened, right? So the value of DevSecOps is to bring down vulnerabilities and maximize test coverage and intensify the automation of security frameworks. This reduces risk, assisting organizations in preventing damage to their brand and financial losses because of security flaws, right? To do this, culture is key, which means that that whole building trust thing that we were talking about earlier, that's really big in this environment because everybody needs to communicate with everybody. Everybody needs to trust each other so that they can believe and understand that, hey, you know what, if I hand this off, if I give this responsibility to this other team member, they're going to actually take care of it. But then it requires that that person actually really does take care of it. So it is one of those things that it is a two-way street, right? So if I trust you to do something, you got to do it. If you don't do it, you hurt everybody, not just me, but you too. And ultimately, it'll be tracked back down to who did what or who didn't do what, because communication is no longer done just by one-on-one face-to-face communication. Communication is done through email and through messengers and things like this. And all of this could be tracked back to, oh, this was your responsibility. This was my responsibility to do. And one of us didn't do what we were supposed to do. And now you're going to get fired. And so this is where it all comes down to, right? So it only works with collective effort. It aims to bridge the security knowledge gaps between the teams and for everyone to think and be accountable for security. They first need the tools and knowledge to drive autonomy efficiently and confidently. So the challenges are this. There's something called a security silo, which, if you know what a silo means, so if we literally, let me see if I could do a Google search for this just so we can kind of see what it is. It brings up a TV series, obviously. So let's go to images and see if we can find, there we go. This is a silo. So a silo is basically a big ass building that contains things. So these are silos. You see this? These are a bunch of silos, right? A security silo. So if you, now that you have the visual, it means that people are left out of the DevOps process because it's a separate entity, right? And where specialized people can only maintain and lead security practices, this situation creates a silo around security and prevents engineers from understanding the necessity of security and applying security measures from the beginning. This is not scalable or flexible because everybody's separate. Everybody is in their own little pocket and they don't communicate and they keep the knowledge, yada, yada, yada. It should be a supportive function to help other teams scale and build security. Without security teams, being a blocker, but rather a ramp to promote secure solutions and decisions. The best practice is to share these responsibilities across all team members instead of having a specialized security engineer. Lack of visibility and prioritization is a result of people operating as if they're in a silo. So to create a culture where security and other essential application components treat security as a regular aspect of the application, that's the goal. That's the culture that you want to make. Developers can focus on development with confidence about security instead of security departments playing police and the blame game and standing over their shoulder and micromanaging them. There should be trust between the teams, and security should promote the autonomy of the teams by establishing processes that instill security. So this is the job of the security team ultimately, is to actually build certain things, certain processes, and put those in place so that as the development team is moving along, you can just make sure that the process that you've developed keeps them on their path that they need to be without you having to micromanage. And as long as they follow a path that you've designed that was a good path, then they don't make any kind of a security mistake. And then finally, there's the stringent processes. And everything must not go through a complicated process and verification against before being used by developers. So this is what stringent means, is that it's super strict, right? Procedures should be flexible to account for these types of scenarios where lower level tasks should be treated differently, higher tasks and changes are targeted for stringent processes. So developers need environments to test software without security limitations. These environments are known as a sandbox, and this is something that you will hear all the time. Sandboxes are not just applied to development of software, they're applied to digital forensics when you're going through some kind of an incident response and you want to launch what you think might be malware and you don't want it to affect the rest of the network, so you deploy it inside of a sandbox. And in the same way, you want to deploy a patch to a software inside of a sandbox before publishing it. So a sandbox is a very important term to understand. And this is the kind of environment that a developer can use to just build the software and see what's up with it, just to make sure that it's actually working. And then they go through the security filters to make sure that it's actually secure as well. And this all happens during the coding and development phases without actually launching and becoming a public product. So this is what's important to understand, is that like all of these things ultimately actually allow for quick development of applications and software and business processes. And the big thing is that like teach them what they need to do, teach the development team what they need to do, give them the best practices, all that stuff, and then put them in a sandbox environment and give them some kind of filtration system that you've developed that says, hey, make sure that you don't do this or make sure you do this while they're developing the code. And then they can test the code as much as they want inside of the sandbox, make sure it actually works. And then once it works, you go over there and you're like, all right, let's look at security and make sure that all of this is good too. So it should be fairly simple once you actually have the trust and people are like, they're really in good communication with each other. So what DevSecOps challenge can lead to a siloed culture? And look at that, security silos. They give you the answer inside of this thing. So security silos. What DevSecOps challenge can affect not prioritizing the right risks at the right times? And that is what? Lack of visibility. And finally, what DevSecOps challenge stems from needlessly overcomplicated security processes? And that is stringent processes. Oh, stringent. God, come on. There we go. I should have just copy pasted that one too, but I wanted to be fancy and type it out and I misspelled it twice. Okay, so let's talk about culture and then we can go do our practical exercise. The best DevSecOps culture, or in my opinion, any kind of culture in a business, has these things. This is what's really, really important to understand. And I'm not going to read this word for word because it should be easy to wrap your head around this. Number one, you want to promote the autonomy of a team. Autonomy means freedom. They should be able to do what they think is important for their specific role in their team. You hire somebody, you give them autonomy to do what you hired them to do. That's what's important about understanding this. And it doesn't matter what size the organization is, it doesn't matter what they're doing, whether it's developing software or whether they're developing widgets. It doesn't matter. You want to hire them, and then you want to let them do what they were hired to do. And you lead by example, promote education like creating playbooks or runbooks, and to help them spot things and fix them earlier, understand the risk and confidence, all of these things. And you're more than welcome to pause the screen and read this word for word, but you should understand what this means without me having to read this word for word. So promote autonomy of the team. Then have visibility and transparency. This is like super, and to me it's very, very common sense, but it might not be for everybody. So visibility means that if you want to build autonomy in the group, then they need to have availability of everything. They need to be able to see everything what's going on so that they can make the decisions according to the information that they have. You don't want to hold back information. You don't want to hold back anything from them. It also means the same thing. Transparency is literally meaning the same thing. You want to be open and honest and give them the information that they need. Now, I understand if you're in an environment where there's security levels, so there's the secret and then top secret and then all of this kind of levels of information. I understand in that environment that there is, you give them everything on a need to know basis, and if they don't need to know certain information, you don't give it to them, but they need to still have visibility and transparency so that they can do their job. So if a dashboard visualizes the number of security flaws by the criticality of the service, this helps prioritize accordingly so people can actually just look at what's going on. So there is nothing lost in the noise, or there is nothing lost in a backlog, and people can attack those flaws at the right time. The security state measure depends on the company, but it could be a number of high findings that a service might find or might not have, which determines if it's in a good security state or not. Transparency refers to introducing tools and practices that are accessible to the teams. If you present a check before merging code, the review doesn't pass and shows a message saying signature or possible code injection flaw detected, please remediate. The developer or engineer should have access to the tool that is flagging that message so they can see what's going on, and then they can remediate. These analysis tools that flag the alerts have a UI that specifies the line in the code that is actually doing this, meaning they know exactly at what line that error was happening or the vulnerability exists, and then they can go ahead and fix it. Again, this is super common sense, but sometimes people don't think about it. And then you account for flexibility thanks to the understanding and empathy. This is more of a human level strategy. This is not technical strategy. This piece right here, technical strategy. UI that tells the specific line of code, that's a technical thing. A dashboard that visualizes the number of security flaws, that's a technical thing. This is a human element. So if you want to get good at cybersecurity, and you'll hear this a lot, you need to be good at dealing with people. You can't just be a coding nerd. I mean, you can, and it's good to have certain technical skills. Don't get me wrong, okay? You need to have technical skills. But it's very, very important, especially if you want to go up the ranks and if you want to work in teams and if you want to ultimately manage teams, which means you would end up getting paid much more money. If you want to do stuff like that, you need to learn how to deal with people, and you got to be flexible. You got to have understanding of what's going on in the environment and how people work. You need to have empathy for people making mistakes or people going through life. Life hits people sometimes and people get distracted, or something happens, somebody's parent passes away, or their dog gets sick, or something. There's like something that's going on with people all the time, and you need to account for that, and you need to be understanding of that. There's a factor that can determine success: the level of understanding and empathy. This means that the definition of risk for security teams is unequivocal, but for other teams, risk can be different and just as precise for them. This doesn't only apply to risk to an umbrella of things. It ramifies into what they prioritize, how they work, what they think is important enough to leave aside a project with a tight deadline to fix a bug. There is no magic tool or process for everybody because you're dealing with individual human beings. It's essential to understand how developers and engineers work, what they know to be a risk, what they prioritize, what are their strengths, right? If you know their perspective, it's easier to build a process that finds common ground and has a higher chance to work versus adding another tool that creates more noise and stress for everybody. Because not everything doesn't work for everyone. That's not how it works. So the understanding builds perspective, which accounts for empathy for how other teams work and builds a process that accounts for flexibility. This is needed because every situation might be different, deadlines might be different, and bandwidth can change over time. So if you're going to be a DevSecOps engineer, suppose you took the time to understand how a team owns a service, and then they'll have a security scanner added to the development process, worked and viewed priority. It'll be easier to get their buy-in and demonstrate value to them. And if it, for example, if it's a platform team and owns an internal service, but a core service, a risk would be a bug that disrupts the service, not a potential injection that lives behind a proxy. You would need internal credentials to exploit it. You can tune the scanners or add triaging processes that tackles the question, and this would in turn build trust versus the crying wolf. The crying wolf is this concept of somebody just complaining and saying that, I don't think this is going to work. I don't think you're doing this right. I don't think this was my fault. I don't think this is my job, right? So it's like if you understand what they're doing, what their actual role is, if you understand what their priorities are in their roles, if you understand how they think, what their personality types are, and all of that stuff, you can finally deliver your solution. So if you want to add a service, for example, you can deliver your solution in a way that they would understand, that addresses their mindset and their priorities, and that gets them to buy in. That gets them to accept the solution that you're offering, and it's very, very important for that to actually take place. So this is a management concept right here. This is a management thing. This is a leadership thing. And you don't have to go into management and leadership, but if you want to, you really need to understand people, and you need to understand how that works. So how can you make security scalable so it's not left behind when startups face hypergrowth or large corporations? And what we do here is we do promote autonomy of a team. So we're gonna just copy paste so I don't have to make mistakes. And how can you support teams in understanding risk and educating on security flaws? And that is visibility and transparency. Copy and paste. And finally, what are key factors to successfully instill security in the development process by accounting for flexibility? I think it's understanding and empathy. Yeah, I believe that's what the answer is. It's not accounting for flexibility. It's understanding and empathy are the two factors that will allow you to do that. And there you go, just like that. So let's do an exercise now. So fuel trouble is the name of this exercise. And we actually have a site that's attached to this. And look at that. There again. Whoever made this obviously loves Star Wars, okay? So, all right, let's go into it. Okay, so here's the story. Sekipo, X-Fighter Dev, Chuba QA, and S2A2 have been assigned to discover minerals in a nearby planet in the galaxy. Watto, the bug, is funding the mission by providing equipment and fuel to carry out the project. They are tasked to set a course and research these planets. So which software development model have they used in each case to achieve the mission? The mission is to travel to the planet with the least amount of risk possible. Accounts for 130,000 light years of travel. The models are Waterfall, Agile, and DevOps. And this is basically what we got. So Comic 1, some tests have passed to go to Testuin, which was the initial decision by X-Fighter Dev. It is decided that it is the next planet to visit. Comic 2, some tests indicated that it's a high risk to travel to Testuin. First, some tests have passed for Nabu, but S2D2 has decided that the course should be changed to Hoth. And Comic 3, the initial decision based on analysis by X-Fighter Dev is to travel to Hoth. Costs were questioned, and although Hoth is one of the closest, Sekipo has analyzed the trajectory and set new parameters for the test. Chuba QA has concluded to change orbit to Dagobah based on further tests. Okay, so let's see here. Okay, so I mean they kind of give it away in these portions right here, but if we look at it here, so we see the code is ready, let's go. Some tests have passed, trajectory to test doing can be done, and systems have been deployed. So code is ready, they tested the code, the systems have been deployed, and now Homeboy comes and says, hey, how are you going to pay for all this? And if we look at this, testing is 125,000 light years, or 125 light years, I guess, and they only have 130 light years of travel. So that's going to be kind of expensive, so on and so forth, which I don't think this even really matters. But this is, they stepped this, they did this, they did this, and then now they're going to do this. And this kind of brings the problem, this last piece brings the problem for the whole thing. And it resembles this thing. They did everything in a hierarchical kind of a manner. So let's see if this is actually right. Waterfall. Yeah, that is right. So what software development did the team in comic 1 follow? All right, so now here's the comic 2. It says, everything is built ready for testing. And then this says, tests have failed. So let's zoom in here. Tests have failed, but they pass if we go to Hackaboo. Let's do that instead. I've developed a new build, but this version is for TryHackMe, and it's better. And then Homeboy is going to say, how's you going to pay for all this, huh? So everything's ready to go. Tests have failed, and we can go to this other thing. So it's kind of like recommending a solution. And then this is another one that says, yeah, but this version is better. And the final result is what TryHackMe is what they're saying. So TryHackMe, 80 light years, and same thing. It's going to come out and say, I feel like this question is going to come up all the time. They have 130 light years. This is going to cost 80 light years. Comic 2. Some tests indicate that it's a high risk to travel to this. First, they passed for Nabu, but S2D2 decided that it should be changed to Hoth. And we're going to say that this is agile. Yeah. And so the hint for this one, by the way, for number 1, the hint was the team decided to stick to the trajectory that was decided from the start, regardless of the hints that only some tests were passed. And then the hint for this one says the team was able to change the course as needed. However, their tests were missing and the planet still wasn't the best option. So finally, we have the last thing right here. And so look, everything is built, ready for TryHackMe. How are you going to pay for this? So it comes up early. Ejecting from the spaceship. They kicked his ass out. That's funny. Test pass, everything is deployed. Let's go to Dagobah instead. And Dagobah, 60 light years away. So this seems to be DevOps. Look at that. So finish, and there's our flag. So not bad. I mean, it wasn't really that hard, honestly. It's kind of a easy, it's like a gimme. This was a gimme. This didn't even require much thinking. But yeah, it was fun. It was cool. Just to see how badly they butchered these characters was kind of fun. And yeah, that's it. That is it for our introduction to DevSecOps. If you had fun in this video, if you learned anything, if it was entertaining in any way, I definitely do invite you to like, subscribe, and turn on that notification bell and join our community. We have had a nice growth spurt in the last couple of days. It was actually kind of crazy how quickly we grew, and it's been really, really humbling and really nice to see what's been going on with our channel. This is literally all the comments that have come in ever since I started this channel, and there's so many people just saying so many cool things, and people are asking questions, and the community is growing. That's basically all I can say, is that the community is growing, and a lot of people have got a lot of really great information from it, and they're providing really good information to each other now. It's like this is one of those things where people are now recommending solutions to each other, and they're talking to each other. And it really is exactly what I was hoping would happen, is it actually turns into a community, and that's exactly what has happened. So it would be awesome to have you as a part of our community as well, if you're not already a part of the community. So would love to see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video. Peace.